Hello everyone and welcome to the channel Explorations with Sean. For centuries, Mars has captivated our imaginations and inspired everything from ancient myths to modern science fiction epics. Known to the ancient Sumerians over 6,000 years ago as Nergal, the god of war and plague, and called the blood-red planet by the Romans, Mars continues to fascinate us like no other world in the solar system. But why all the hype? Today we're going to explore Mars's storied past, discuss how it became the barren planet we see now, and dive into the age-old question: could there be life on Mars? Ancient and classical views. The Sumerians saw Mars as a deity of war and plague, while the Romans named it after their god of war, Mars. The Greeks knew it as Ares, and in ancient Chinese astronomy, it was called Yin Kuo, meaning the perplexing one. Fast forward to 1610 when Galileo pointed his telescope at Mars. For the first time, he saw its reddish-orange disk and noticed what appeared to be polar ice caps at the top and bottom of the planet. In the late 18th century, William Herschel used a 20-foot telescope to observe these caps expanding and shrinking. Scientists of that era thought this indicated the freezing and melting of liquid water with the Martian seasons, fueling speculation about life on the red planet. In 1877, Italian astronomer Giovanni Schiaparelli endeavored to create the first detailed map of Mars. He drew straight lines he called canali, which translates to channels or grooves. However, the term was widely interpreted as canals, sparking rumors that Mars had vast irrigation systems built by an advanced but endangered civilization. This misunderstanding inspired classic science fiction tales like H.G. Wells' The War of the Worlds and Edgar Rice Burroughs' John Carter series, both depicting a dying Martian society. Eventually, better telescopes revealed that these lines were merely optical illusions. The polar caps turned out to be mostly dry ice, solid carbon dioxide, not just frozen water. Still, the belief in Martians had taken hold in popular culture, an obsession that continues to this day. Mars is one of the 4 terrestrial planets, alongside Mercury, Venus, and Earth. It's about half of Earth's diameter and roughly 14% of Earth's mass. Gravity there is about 37% of Earth's, meaning you could jump much higher, or even dunk a basketball with ease. With an axial tilt of about 25.19 degrees. Earth's is about 22.5. Mars experiences 4 seasons, just like Earth. However, each season lasts nearly twice as long. About 6 months of summer and 6 months of winter. Length of day and year. A Martian day, often called a sol, is around 24 hours and 40 minutes, very close to an Earth day. But a full Martian year takes 687 Earth days, meaning you'd celebrate fewer birthdays if you lived there. Despite its current desolate appearance, evidence strongly suggests Mars was once a watery paradise. To understand why it changed, let's go back 4 billion years to the Noachian period, a time when Mars was young and volcanic activity was intense. Despite its current desolate appearance, evidence strongly suggests Mars was once a watery paradise. To understand why it changed, let's go back 4 billion years to the Noachian period, a time when Mars was young and volcanic activity was intense. When Mars' core was molten, it generated a strong magnetic field capable of shielding the planet from the sun's damaging solar wind. This protection allowed a thicker atmosphere to form, warming the planet enough to sustain liquid water on the surface. The Tharsis region, home to the massive volcano Olympus Mons, the tallest in the solar system, erupted with enough magma to release large amounts of carbon dioxide and water vapor. Some estimates say that if the early Martian water were spread evenly, it could have covered the entire planet in a layer 120 meters deep. Geological features like dried riverbeds, massive canyons, and ancient lake basins indicate that up to 36 to 75% of Mars's surface might have been covered by water. The northern hemisphere, which is lower in elevation, likely housed a vast ocean. In smaller basins or craters, lake systems may have rivaled Earth's large lakes. Hot springs and hydrothermal vents suggested by the presence of silica in Martian soils are prime locations for the origin of life on Earth. Could a similar process have happened on Mars? Possibly, until repeated asteroid impacts and eventual atmospheric loss changed everything. Cooling core. Mars is much smaller than Earth, only about half the diameter, which means it loses heat faster. Over time, Mars's once molten core cooled and mostly solidified. Without the molten core, the protective magnetic field faded away. Atmospheric stripping. Without a magnetic shield, solar winds bombarded the Martian atmosphere, blasting it into space. As the atmospheric pressure plummeted, the water on the surface either evaporated or froze, dooming the possibility for large-scale life on the surface. Early in its history, Mars may also have suffered a massive collision. Some believe an object up to 1,600 kilometers in diameter slammed into the planet, reshaping its northern hemisphere, known as the Borealis Basin, and possibly destroying any nascent biosphere. Life on Earth demonstrates incredible resilience. Consider the tardigrade, also known as the water bear. In 2007, tardigrades were exposed to the vacuum of space for 10 days and returned alive. When water is scarce, they desiccate, losing up to 97% of their body water, slowing their metabolism to near zero and reviving when rehydrated, sometimes years later. Tardigrades survive temperatures above 150 degrees Celsius and near absolute zero, minus 273 degrees Celsius. They also produce antioxidant shields that protect them from harmful solar radiation. Could a Mars-adapted extremophile have evolved similarly, staying hidden underground or dormant until conditions briefly improve? It's a big leap, but it shows life can endure conditions even more extreme than those on Mars. Liquid water today? Liquid water today. Recurrent slope lineae, or RSL. NASA's 2015 announcement confirmed that Mars occasionally has flowing liquid water, albeit highly salty brines. These brines appear as dark streaks on steep slopes during warm seasons. Toxic perchlorates. The water is laced with perchlorates. Salt's toxic to most known Earth life. Still, some Earth bacteria do metabolize perchlorates, suggesting maybe an underground Martian microbe could manage something similar. Methane is unstable in the atmosphere, so something, be it geological or biological, must be producing it. On Earth, most methane is biological in origin. Might there be methane-producing microbes or methanogens under the Martian soil? A4001 and others. Over a dozen Martian meteorites have been found on Earth, including the famous A4001 from Antarctica and the Nakhla meteorite from Egypt. Some contain microscopic features resembling fossilized bacteria, plus organic compounds and amino acids. Although none of this is smoking gun evidence of life, it strongly hints that Mars could have once hosted living organisms. Radiation. With a weak magnetic field, the surface is bathed in ionizing solar radiation. Any life likely has to hide underground. Lack of nitrogen. Earth's nitrogen-rich atmosphere supports life. Mars doesn't. Although Curiosity found nitrate byproducts in Martian soil, levels are still too low for surface ecosystems to thrive. Low atmospheric pressure. The thin air could cause cells to burst if they haven't adapted to extremely low pressure. Yet life, if it started billions of years ago, might have gradually evolved to cope with these extremes. Scientists now see Mars as a place that was once habitable, and possibly inhabited about 4 billion years ago. Scientists now see Mars as a place that was once habitable, and possibly inhabited about 4 billion years ago. Some even propose that life started on Mars first, and then came to Earth via Martian meteorites. It's a far-out idea, but not impossible. Microbes in ejecta from a colossal impact on Mars could have crash-landed here, helping to seed life on our planet. So, is there life on Mars today? We still don't know for sure. NASA's rovers primarily look for habitable conditions, rather than life itself, and future missions aimed at drilling deeper underground might be the key to uncovering any surviving microorganisms. That's the story of Mars. Once a vibrant, water-rich world that now sits cold and barren, yet its allure endures. From ancient Sumerian myths to modern rovers trundling across rust-colored deserts, Mars fuels our imagination about life beyond Earth. If you enjoyed this dive into our side Red Planet's mysteries and want more cosmic exploration, give this video a like and subscribe for future episodes. Let me know in the comments what you think. Did Mars once harbor life, and might there still be something lurking below its dusty surface? Thanks for watching, and I'll see you next time.